This is a challenge problem because it has two reactions going on in here. So the first reaction, let's just read the problem. A student added 50 milliliters of a sodium hydroxide solution to 100 milliliters of 0.4 molar HCl. So they're doing a neutralization reaction right here. The solution was then treated with an excess of chromium nitrate, resulting in the formation of 2.06 grams of precipitate. So there is a second reaction, and it's a precipitation reaction going on. And what they want us to do is determine the concentration of the sodium hydroxide solution. We know that we started with the 50 milliliters of sodium hydroxide, but we don't actually have the molarity of the sodium hydroxide. So let's just do this step by step. Okay, so the first step, they're doing a neutralization reaction. And the neutralization reaction is between sodium hydroxide and HCl. We know how much HCl we needed right here. So it's a neutralization reaction, so it's going to make water. And we're also going to have sodium ions and chloride ions. I'm just going to put them as sodium chloride. All right, so a little bit of a calculation right here. I had 100 milliliters of HCl. I'm going to convert the milliliters to liters, so 0.1 liters of HCl. And I'm going to multiply that by the molarity of HCl, which is 0.4. So I know that it's a 0.4 molar solution. That means I have 0.4 moles of HCl for every liter of the solution of HCl. My liters cancel. Boom, boom. And that means that whenever I did this neutralization reaction, we actually neutralize 0.4 moles of sodium hydroxide, because that is exactly the same number of moles of HCl that we need. So this calculation gives you the moles of HCl. I jumped the gun and put moles of sodium hydroxide. But it's a one-to-one reaction, notice. So for every mole of sodium hydroxide, I will consume 1 mole of HCl. So I'm going to have the same number of moles of sodium hydroxide as I have of HCl. All right, let's go to the second part. That's a little bit more complicated, but not too much. Nothing to worry about. So it's a precipitation reaction. So the first reaction, I consume 0.4 moles of sodium hydroxide. There was something left over because then it reacted with chromium nitrate. So we need to actually have the equation. So we have the chromium nitrate reacting with the sodium hydroxide. And it forms a solid. The solid is going to be chromium hydroxide. And chromium is 3. We know it because it has 3 nitrates. So I'm going to need 3 hydroxides as well. And we're going to have sodium and nitrate ions. And we're going to need actually 3 of this. So let's balance the equation really quick. There we are. You see I had 3 nitrates over here. Now I have 3 over here. That means I need to have 3 sodiums over here, and 3 hydroxides, which is what I have here. All right. I know we formed 2.06 grams of precipitate, and this is the solid that we formed. This is the precipitate, the chromium oxide. The molecular weight of chromium oxide is 103.02 grams per mole. So we're ready to do this. Let's start with the 2.06 grams. We know that it's chromium trioxide. We know the molecular weight. So let's convert the grams to moles. So 103.02 grams is 1 mole of chromium trioxide. According to this equation, for every mole of chromium that I have, I'm going to need 3 moles of the hydroxide. So I have to take that into account. For every mole of chromium, I'm going to need 3 moles of sodium hydroxide. You can put sodium hydroxide. I put the hydroxides in there. And this is going to give us, real quick, I already calculated it. That the precipitation reaction by itself used 0.06 moles of sodium hydroxide. All right, so let's go real quick. I have the first reaction used this much sodium hydroxide. The second reaction used this much sodium hydroxide. So there was enough sodium hydroxide in the reaction for both reactions. So I'm going to add this real quick, and that gives me that I had 0.1 mole of sodium hydroxide in my original solution right here in the 50 milliliters of sodium hydroxide that they gave us. All right, so let's do molarity. Molarity, remember, is defined as moles over liters. Can I move this a little high? No, it's stuck. Here are my moles of sodium hydroxide, 0.1 moles of sodium hydroxide. Over the liters, I have 50 milliliters of a sodium hydroxide solution. If you want to convert the milliliters to liters, go ahead and divide by 1,000, or you can move the decimal point 3 spaces to the left. So that gives us liters. And it turns out that the original solution of sodium hydroxide was a 2 molar solution. Again, this is a little bit more intensive problem than the others, but you see a neutralization reaction that uses sodium hydroxide, followed by a precipitation reaction that also uses sodium hydroxide. And then you calculate a molarity.